I want to share some experiments I've been doing with what I'm calling selective drop printing, where part of the model, in this case the holes inside of this vase, have been printed with different slicer settings to cause the dramatic change in the look of the print. These are small holes. You can also do big holes. I've got a model that I'm going to share with you that allows you to change all these settings. Now, exactly what's happening here. On the left, we've got a normal print setting. Nothing's been changed. On the right, I've got the drop print settings, where you can see that a lot more material has been put down, and it forms this cool loopy organic pattern. To see what it means, this might help you even better. Here's the printer. It's printing the wall part of the vase. It's going along normally. This is typically what you'd see, and now it'll change its behavior. When it prints the part that goes on the inside of these holes, it's going much slower, and it's extruding a lot more plastic. It has to go slower because if you're going to extrude a lot of plastic, you can only get it through the nozzle so quickly. It can move faster when it's printing the walls because it's depositing a lot less plastic when it's doing the walls. So this is basically something you do in the slicer. You have to have two different STL files to make it work, and I'm going to show you how to do all of that in this video today. This is what it looks like when it's done. This is just one application of what I'm calling, drop printing or whatever. You can do a lot of other things, and I'll probably have more videos showing other ways that I'm goofing around with this. You can see, you can kind of control how tightly it fills the shape of it a little bit. This is one that I made using the Cura fuzzy skin setting for the wall part of the vase. Okay, so first we're going to start with openSCAD, which is also free. Okay, so I'm going to go over the settings and how to actually get this print to work with Cura and how to export the files from the openSCAD program. What we're doing is we're drop printing some fill for these circles on this vase. So when I say drop print, I'm going to refer to the part of the model that's on the inside of this circle. The other part of the model is going to be normal, and in order to use Cura's print per model settings, we're going to generate two STL files, and one of them is going to have different print settings so that it will extrude more plastic during that part. So right here, these two wall settings here, I have an Ultimaker original, so my nozzle size is 0.4. I want to have just a basic vase for like decorative purposes, so my walls are going to be 0.8, which is 2 passes of the nozzle. So that's why I've got my real wall set to 0.8. The real wall, if you make that bigger, and then you can preview it, so you can see that now this part is thicker. That's the real wall. This part on the inside thickness hasn't changed at all. That's the drop print part. If I change that thickness and preview that, you can see that now that part is thicker too. So those can be adjusted independently. I really haven't actually printed with anything other than both of them set at 0.8. The tall, that's just the height of the vase. How tall is it going to be? The radius is how big is the vase going to be. The base is how thick is this bottom part going to be. The drop R is the radius for these holes here, the drop print part. So if I make that smaller and preview it, you can see we've got smaller holes. If I make it bigger, we end up, and this is probably going to break the model. Yeah, so you can't make it too big unless you make the radius of the model big. So I'm going to go with 12 right now. And now I want to talk about the actual the drop print part. So this part here, the part that's going to be printed with different settings, that's going to, when the printer is coming across here, it's going to stop printing, it's going to start printing here, and it's going to print a whole bunch of plastic just in the air, and then it's going to stop printing, and that's going to print more of our normal model. This is all going to drop down here and accumulate as loopy organic blobs and shapes inside of this cavity. When this slop value here, that's the gap that you're seeing right there. So if I make that a 0 and preview it, there's not going to be any gap at all. what I was finding is when I made it with no gap, it would be printing along, it would start extruding a bunch, and then this would be so close to there that it would kind of bunch up right there, and I would get a bunch of bunching up in the corners. So I wanted to give it a little gap so that it would fall more into this bottom part and fill that up more quickly than bunching up in the corners. But then when it got to the top, if I had a gap there, it would be a little fragile, and I would worry that this would pop out. So I added this Z drop scale. So if I change this back to 0 to 1, which is no scaling, you can see that there's it's gonna not be attached at the top. But I wanted to have these last few layers at the top be actually attached to give the model some strength. So if I preview that, you can see that by stretching this up, these last 3 are actually going to be holding on better. This is what it looks like when drop Z scale is set to 1. There's nothing connecting the top of the drop print part to the rest of the vase, whereas here I've got the drop Z set to like 1.2 or something, and that way the top of the drop print part is attached to the vase and it holds inside the hole better. The drop space value is how many layers to skip between generating this. So if it was 1, that's basically don't skip any layers. It's just going to be solid. When I printed that way too much material was getting deposited in this space and it didn't look good. It was kind of bunching up. So I'm using a 7. You know, if I made this a 2 and previewed it, you could see that basically that means every other layer generates something to go in there. But 7 seems to be working pretty good for me now. That way it kind of fills it up but doesn't overfill it. The slice value is how thick this is going to be. That's the thickness you're slicing it at. So like if I made this an 8 and previewed it, you'd see that these are a lot thicker, and it's skipping 8 and then going again. I'm going to print at a 0.2 layer height. So that's what I'm going to slice my model at, so that's what I'm going to use here. So those are the settings. Now let's make an STL file. Excuse me. So the first thing is this print what, having that set at 3 right now is what I use to visualize as I'm designing. But what we need is actually 2 separate STL files. We need one that's just the vase and one that's just the drop part. So I'm going to set this to a 1 and I'm going to preview that. That's just this vase. So I'm going to render that. And then I'm going to, it says rendering finished, so I'm going to export that as an STL file. And I'm going to call this part 1. And I'm going to save that. Then I'm going to change this to 2. And we can preview that. And you can see that now it's doing just that part. So I'm going to render that. Finished rendering. Export as STL. And this time I'm going to call it part 2. So I have 2 separate STL files. Okay, now we're done with openSCAD. Let's go to Cura. So I'm using the normal print quality, and I'm going to change a bunch of the settings, but I figured I would just start there so we all have a shared baseline. That's the default profile that comes with it. So I'm going to open both of the files that I just exported, part 1 and part 2. It's going to import them, and it's going to look like this. Now, what I want to do is select the part that's going to be the drop printed part, and this button here is for per model settings. So I'm going to click that to turn it on, and then I have to select the settings that I want to be different than the rest of the things. And in this case, we're going to change the flow and the wall print speed, because this model's the thickness is only 0.8, so basically everything is a wall as far as the slicer is concerned. So then I'm going to close that, and so you can see that this one's using that and this one's has ability to change the flow and the wall speed. So let's go over here now and look at our normal print quality, and we're going to change some of these. So my layer height I'm going to want to be at a 0.2, the initial layer height, I'm also going to make 0.2 because I didn't actually, that goes into this, how these are done, but I didn't change the calculations for those heights. Sometimes, let me go back here for a second. So here, this is getting more detailed than I wanted to, but anyways, if these layers, if this part of the model isn't the right height from the bottom, when your slicer comes along, it may not generate G-code for that part of the model. If, for example, your initial layer is like 0.3 or something, then some of these might be off a bit, and it wouldn't generate G-code for it. Probably at a 0.2 slice thickness, that's not a problem, but if you were trying to do 0.1 or some other thickness here, that's a danger. So anyway, I'm going to set the initial layer to that. Line widths are good. Everything should be 2 passes. Wall thickness 8. That's good. That's what I had in my SCAD file. That's how thick the walls should be. The bottom and top layers, that's not going to matter for this model. The infill, I don't need any infill. I'm just going to put that to 0. This is all walls. No infills needed. Because I'm going to be printing kind of fast, especially in the middle part, I might be extruding a lot of plastic. I'm going to crank up the temperature a little higher, a little hotter than I would normally print at for PLA. I use blue tape, so I don't, and I just pick my bed temperature more like at normal room temperature. The diameter of the filament, I hardly ever find it's a 0.85. Practically all the filament I'm measuring is thinner than that, so I usually put a 0.8. 100 is good, and retraction's fine. All this stuff is okay. Some of it doesn't matter. Speed, that's fine. So the wall speed, I actually do want to have the same as everything else. Top and bottom speed, that's fine. Initial layer, that's fine. Brim, speed, it's okay, whatever, it doesn't matter there. Traveling is fine. Cooling, now I don't want the fans to go on because when this starts, this drop print happens, I don't want the fan blowing it. I just want it to fall straight down. So I'm going to turn off my cooling fans. You can't actually turn any of this adhesion garbage off, so I just usually set the brim line count to 0, and then that'll make it so that doesn't happen. I thought there was something about, I think for this, for the purposes of this particular model, I think that's all I need to change in these settings. Although, yeah, okay. Now, we're going to come back to this part. Remember, this was the part we wanted to print a lot more. So we're going to decrease the speed by a factor of 10, and we're going to increase the flow by a factor of 10. That way, when it gets to printing this part, it's going to move really slowly and squirt out a ton of plastic. So that's it. So now I'm going to select both of them by shift-clicking, so they're both selected. Then I'm going to go up to Edit. I'm going to ask it to merge the models. So then it puts them both together. And then why don't we just do a quick layer view so to kind of get a look at what's happening. So basically, you can see that when it gets to print this part, it's kind of showing us that it's going to print a lot more plastic in there than the normal wall part. So that's looking good. I think the last thing I'm going to do is I'm just going to move the model just over to this corner because my web camera is over here in this corner, and it'll probably film it better if I stick it over there. Alright, so then I'm going to, I'm going to save to removable drive. Yep, that's what I want to do. So I'm saving my G-code, and now I'm going to go to the printer. So that's it. ready to go. Okay, I'll just finish up with a time lapse of that vase with the big holes printing, so you can see what that looks like. And then I put some other videos here at the end just to see what the printer looks like when it's doing the printing. So if you try these, you'll know what the printer's supposed to look like, what the sounds that change, and how it moves. Enjoy. I'll try to post a bunch of this up also on the on my Imagine page or my Thingiverse, I don't know, wherever. Alright.